Okay, we're going to talk about antiderivatives today. Our learning target, I can use a derivative to find a general and specific antiderivative. So let's start by defining antiderivative. An antiderivative is a function that has the given derivative. What am I talking about? Well, if f of x equals x squared, then we know that f prime of x would equal 2x. Therefore, we would say that x squared is an antiderivative of 2x, because if we take the derivative of x squared, we get 2x. We are doing differentiation backwards. That's what we're doing here. So let's look at a couple of other derivatives. Take the derivative of f of x equals x squared plus 4. Now take the derivative of f of x equals x squared minus 6. Now take the derivative of f of x equals x squared plus 1/3. What do you notice? All three of those functions have the same derivative, which means all three of those functions are antiderivatives of f prime of x equals 2x. So we say a general antiderivative has a constant c added on. If f prime of x equals 2x, then cap f of x equals x squared plus c. c is the constant added on. It is common to use capital F of x for antiderivative. Okay. So we're going to do an example. We're going to find the general antiderivative. The example is f of x equals 1/2 x squared minus 2x plus 6. We're going to work the power rule backwards, one term at a time, because we are asking ourselves what function has f of x as its derivative. Now I want you to think about the power rule. The power rule says that you multiply the exponent and the coefficient, then you subtract 1 from the exponent. We're going to work this backwards. That would mean backwards, the power rule is add 1 to the exponent and then divide the coefficient by the new exponent. So let's look at this one term at a time. Our first term is 1/2 x squared. We're going to add 1 to the exponent. So 1 plus 2 equals 3. Then we're going to divide the 1/2, divide the coefficient, by the 3. So 1/2 divided by 3 equals 1/2 times 1/3, because it's a fraction, equals 1/6. So the term is actually 1/6 x cubed. If I take the derivative of 1/6 x cubed, I will get a derivative of 1/2 x squared. Okay, the next term is negative 2x. I'm going to add 1 to the exponent. The exponent on this one is 1, so 1 plus 1 equals 2. I'm going to divide negative 2 by 2, and negative 2 divided by 2 is negative 1. So the term is a negative 1x squared. The last term in this particular function was a 6. What has a derivative of 6? So that's going to be 6x. So if f of x equals 1/2 x squared, minus 2x plus 6. Then cap f of x equals 16x cubed minus x squared plus 6x plus c, because I can have a constant added on at the end, and that can be any value. An error alert. Students love to leave off the c. Okay? Now, what if I need to find a specific antiderivative? A specific antiderivative is when we actually locate the specific c value. So our example is f of x equals x plus 2 sine of x with a condition that cap f of 0 equals negative 6. So when x equals 0, the antiderivative equals negative 6. So first we're going to find cap f of x. We're going to find the antiderivative of f of x. So we know f of x equals x plus 2 sine of x. So cap f of x equals, well, let's look at the x. The exponent would have been 1, so 1 plus 1 is 2, and 1 divided by 2 is 1/2, so that's 1/2 x squared. The next piece, we have 2 sine of x. Well, what gives us a derivative of positive sine? Negative cosine has a derivative of positive sine. So my antiderivative is negative 2 cosine of x, and then I have plus c because I can have a constant on the end. Now, I do have to apply the condition to find c. So we know that negative 6 has to equal the cap f of x when I substitute 0 in for x. So negative 6 equals negative 2 times 1 plus c. Obviously, 1/2 times 0 squared is 0. The cosine of 0 is 1. Negative 2 times 1. That's where that came from. So negative 6 equals negative 2 plus c. We add 2 to both sides of the equation. Negative 4 equals c. And my specific cap f of x equals 1/2 x squared minus 2 cosine of x minus 4.